Hey guys, so last we looked at the cone problem, and the goal of this problem was to make the largest possible cone by volume from a circle with a radius of 3 inches. So if I was going to draw this, the idea is that we would take a circle with a radius of 3 inches, and we would cut some of this out, and then attach these two pieces and create a cone with it. And we want the cone that has the best combination of height and radius to give us the biggest volume here. So to play with this a little bit, first we're going to look at an actual piece of paper and we're actually going to cut it and make it into a cone. So I've got a circle here with a radius of 3 inches. I'm going to cut down that radius so we can play with it a little bit. And now I can make a cone out of this by sliding that together, and I start getting a cone shape. Now, the more I slide it around, okay, I'm going to make a smaller circle, but it's going to have a higher height. And I can slide it tighter and tighter and tighter, and each time I do it, I'm going to keep getting a cone that's a little bit taller, but with a little bit smaller radius around the top. So the idea is, what do I have to cut out here to make the best cone possible? Well, so to start with, we're just going to play a little guess and check. I'm going to start by guessing these. Actually, 60 will be easier to work with because 60 goes into 360 a little bit better. So start with 60 degrees. I'm going to use my protractor here and mark out 60 degrees. Then I'm going to cut that out of my circle, that sector out. So cut through. And now I've got that piece removed. Okay. I would tape these two edges together to form the cone, assuming that there's no overlap, like I could just put a piece of tape there. And now I've got cone shape. Okay? And the question is, what is the volume of this cone if I've taken out a 60-degree sector? Well, let's go ahead and do some math on the paper now to take a look at that. Okay. So I'm going to make my drawing a little more precise. This is 60 degrees, I'll label that. And I know in a full circle 360 degrees, so that means the degrees left are 300. Okay. I notice that when I'm doing this, I'm going to need the circumference formula for a circle. The circumference of a circle is 2 pi r. In our case, the radius is 3 inches. So our circumference is going to be 6 pi inches for the circumference of our circle. And since we only care about the arc length of the part that's not cut out, we don't care about the 60, what we really care about is the 300. 300 out of 360 degrees is going to be the arc length. So this fraction of the circle, that fraction of 6 pi, is what I'm talking about for my arc length, which I'm going to call A for right now. Okay. Now I can reduce here. I can cancel some zeros out. Let's see, what goes into 30 and into 36? 6 goes into both. 6 goes into 3 5 times. 6 goes into 36 6 times. And then here, this kind of worked out nicely. I have a 6 on the bottom and a 6 on top, so I can cross reduce there. So I end up with 5 pi for my arc length. That means that this part around the outside of the circle, for me right now, 5 pi inches. And this part right here would have to be pi inches because that's what I've got left. So on the bigger circle, if you wanted to look at the actual model, this piece that I have, there we go, sorry, so this piece out here is 5 pi inches, and this missing arc length right here is pi inches. Now notice that when I put this together and I glue it, the circumference here for my cone is now that arc length. The arc length that I just found, 5 pi, is the circumference of the cone. So that means on my picture here, this circumference of the circle of the cone is my arc length right here, so this must be 5 pi inches for me. Now I can use that fact to find the radius of the cone. So the circumference of the cone is 5 pi inches. I'm going to divide both sides by 2 pi. Those cancel, and I get that the radius of the cone right now, the radius of this guy, is, let's see, 5 over 2 inches. Okay, so if I were able to do this really carefully, if I were able to close off this cone, tape it, and then very carefully measure the radius of this circle, it should be 5 over 2 or 2.5 inches. Okay. Now that I've got the radius, in order to find the volume of a cone, I'm going to have to know the height. And so notice here that I've got a little right triangle. Okay, and the radius is 2.5 inches, or 5/2 inches. And I also know something about the hypotenuse of the cone. Do you see here that we've got this radius of 3 inches? I'm going to move this out of the way so you guys can see it on the actual model. We've got this radius of 3 inches. If I tape my pieces together, that radius of 3 inches ends up being the hypotenuse, that edge of the cone, the side of the cone. And so here I know that the hypotenuse I've got here is 3 inches. Okay, which means I can use the Pythagorean theorem, or I could use trig, to find my h. So let's see, Pythagorean theorem says a squared, so h squared plus r squared, that's 2.5 squared, equals 3 squared. That means h squared plus, I'm going to leave this as 5/2 because it's going to be easier to square. If I square the 5, I get 25, and if I square the 2, I get 4. 3 squared is 9. And then I'm going to take 25/4 away from both sides, so h squared is 9 minus 25/4, whatever that is. I don't have a calculator on me. I could get a common denominator. Oh, might as well. Let's get a common denominator. Multiply both sides by 4. 4 times 9 is 36. 36 minus 25 is 11, I think, over 4. So I get h squared is 11/4, and then I can square root both sides to get my h. So I get the square root of 11, and then when I square it 4, I get 2 on the bottom. Okay. Now that I know my radius and I know my height, I can find my volume. The volume formula for a cylinder, or for, sorry, a cone, is 1/3 pi r squared h. Okay, so I'm going to get 1/3 pi times r squared. Now remember, r was 5/2, so I'm going to have 5/2 squared times h, which was root 11/2. So I would throw that into my calculator. Let's see, but since I don't have a calculator on me, oh yeah, never mind. I've got one of those handy. So let's see, let's do some math here. I've got 1/2, so 0.5 times pi times 25/4 times the square root of 11. Make sure to get out of my square root there, divided by 2. And I get 16.28. And that would be inches cubed, or cubic inches, because it's volume. Okay. Now, the goal isn't to find one volume. The goal was to find the biggest volume. And so I just wanted to give you guys these notes just in case in class you were struggling a little bit with finding the volume in the first place. I figured that you could watch one at least and then try to work through it yourself. So if you note on the blog, your guys' homework is to do this same process again, but instead of 60 degrees, I think I asked you guys to do 100, and then 110, and 120, and so on. So make sure you check the blog about which ones you're supposed to work out. And also, when you work these problems out, make sure, please, that you're showing all of the math on the paper like I did here, and showing your diagrams for each of the problems and labeling the diagrams. It's going to actually help you in the long run to really be thorough in showing all of your work and writing the diagrams accurately. All right, that's it for the cone problem for tonight. Thank you.